what we do in this side of the lab is we do all the testing on the cements and the fly ash. The cement is basically what glues everything together. And we bring in all the aggregates, the rock, the sand, all of that, and that's the bulk of the concrete. But what glues everything together and makes it nice and tight and hard is that cement that we test around here. So all this equipment that you see around here is to test the cement. What the concrete industry has done recently is we've started using some replacements for the cement. Cement is an intense CO2 producing material just by the nature of it. So we started using byproducts from other industries like slag cement from the steel industry. We're using the fly ash that the thermoelectrics waste in order to produce the electricity. When they burn all that coal, the ash that is left behind, we put it in silos and we use it to replace some of that cement. So we're not only using byproducts from other industries and avoiding those products to go into landfill, but we're also making our concrete have better properties. We're using less of the cement, so we have a greener concrete. It's more sustainable. And in order for us to use all those byproducts, we need to test them on a regular basis, because all these other industries do not produce these byproducts for us to use. It's just waste for them. So we need to make sure that they are not contaminated with other stuff that they produce, other chemicals that they do. And we bring it in here and we do all the testing from the powder. We mix it with some of the sand, we do some mortar, we do some of the breaks on just cubes for the cement and the fly ash, and then we measure some of the length changes throughout the life of that paste. That's what we use these molds, and that's what we have over there as a gauge. And we have ovens and we have freezers, and the ovens and the freezers are used to simulate what what concrete is going to face out when they're in a building, when they're in a pavement, when they're on a sidewalk. We put them under intense heat, like they would go through the summer. We put them under intense cold, like they would do on the winter, and we see how they perform.